So far we've been looking at how to organize information about different material categories, and also looking at how we organize information about processing materials. And this video is about ways to display the properties of materials when you're looking across different material categories. So if you go to page 23 in the Ashby text, you'll see two figures there, figure 2.8 and 2.9, that illustrate two different ways that you can display the information. So I just want to point out a couple of important features. One is that you can see in this top figure 2.8, I'll expand it a little, that you're looking at in this case, a measure of the stiffness, the modulus of elasticity, and along the x-axis are essentially just different material categories. You see the metals, polymers, ceramics, and the hybrids or composite materials. On the y-axis, notice that it's a log scale, so each movement from this line to this is a decade. So materials down here, and these happen to be, this light blue happens to be elastomers. These materials have a modulus of on the order of 10 to the minus 3 gigapascals. And if you go up 1, 2, 3 lines, you're looking at factors of 10. So this is 10 to the third times larger Young's modulus than the elastomers down here. And then you could see metals here span in order of 10 to the, let's see, 1, 2, 3, 4, 5, a little more than 10 to the fifth times larger modulus of elasticity than these elastomers. So you can see that the material categories are sort of grouped together. The metals have displayed maybe a decade range in their modulus of elasticity. The polymers have a huge range here. We're looking at 4 to 5 decades of range of this modulus of elasticity. Again, the ceramics, which are the high-tech ceramics represented by these groupings of materials up here, and the sort of glasses or amorphous ceramics are down here. They have about a range of a decade of modulus elasticity. And then we have the composites over here, which are typically mixes of these different sets of materials, where you're trying to leverage the aspects of the materials themselves. So in graphite fiber reinforced composites, for example, you're trying to take the strength afforded by the graphite fibers and the processing flexibility afforded by the polymer matrix that you are embedding that in. And you can see that you're getting some of the properties of both. So you get the polymer matrix, which pulls the modulus down, and you get the strength of the graphite fibers, which are a ceramic, and that pulls the matrix up. So the graphite fiber reinforced composite is somewhere in between the properties of those two. Now the bottom chart is another way of representing the same information, although this time along the x-axis the density is displayed. So you could see the range of densities for these materials. And once again you have a log scale on the x-axis and on the y-axis, and this time groupings of materials are designated by a color band around the grouping of materials. Here are the elastomers, the polymers are here, natural materials are this darker green, whereas you can see that this orange area represents metals, technical ceramics in the yellow, composites in the purple, and the foams down here. Now in the software that we're using for this class, you can generate a number of these different charts so that you can examine together what are the commonalities, or comparing something like the modulus elasticity or strength of a material against its density or some other parameter.